Let's start with a quick review of what we learned yesterday about GCF, and I'm going to give you some tips to actually make your process a little bit faster, okay? So let's say I'm looking to find the GCF, okay? And we're going to build on this in just a sec. Let's say I'm looking to find the GCF of 8, 16, and 20. Here's what I'm going to do. I'm actually going to take a look at just a smaller number for a second, and I'm going to think about how I would factor this, and I would factor it as 4 times 2, and then I could keep going as 2 and 2. But look, what I want to identify is that the factors of 8, right, because I'm looking for factors, the factors of 8 are 1, 2, 4, and 8. And notice, right, 2 and 4 I found here, and 1 and 8, like 1 and the number are always going to be a factor of a number. So these are the factors. Now, what I'm looking for is the greatest common factor. So these are the factors of 8. Notice I chose the smallest number. And what I want to do is find out which of these factors is common and which is the greatest common factor. So I'm not going to start at 1. I know 1 is common. And in fact, 2 happens to be common as well. But what I'm going to do is instead I'm going to start with the greatest number, because that's what I'm looking for, is the greatest common factor. So let's start with 8. Does 8 multiply to 16? And look, if you're not so hot with your multiplication tables, what you can do is use this as a tool and say, does 8 multiply to 16? And it does, it's right here. Okay, and then you say, okay, good, okay, 8 is a common factor so far. Does 8 multiply to 20? And you look and you're like, oh, no, it doesn't. So 8 is not a common factor because it multiplies to 1 but not the other. Is 4 a common factor? Does 4 multiply to 16? Yes, it does. Okay, so 4 works so far. Does 4 multiply to 20? Yes, it does. So there we go. 4 is the greatest common factor. Okay, I found all the factors of the smallest number, and then I started at the biggest, right, and saw if it was common or not. The 8 was not common, okay, and the 4 was. And then remember, we also talked about doing this same process when I had monomials that might have variables in them. So here's 3 monomials. Let's find the greatest common factor. And what I'm going to do is I'm just going to treat the numbers and the variables completely separately. So I'm going to start with the numbers, and what I'm going to do is I'm going to look at the smallest number, right? I'm looking at the smallest number. I find the factors, and the factors are just 1 and 2. So the question is 2 a greatest common factor? Does 2 multiply to 4? Sure does, right? Hopefully you don't need the multiplication table for that. Does 2 multiply to 10? Sure does. 2 times 5 is 10. So 2 is going to be the greatest common factor for the numbers. And then let's look at the variables, right? This is, and you can write it out if you need to, but you might not need to. This is x times x times x here. This is x times x, and this is x. So how many x's are in common? Well, there's an x here, an x here, and an x here. Is there another x in common? No, there's not, because there's not any more x's here. Yes, there's more x's here. It doesn't matter. We're looking for how many x's are common across each term, and it's just the 1, right? There's only 1 x that each term has in common. So here the greatest common factor would be 2x. All right, so just before we move on, you try. And I'm telling you right now, I'm giving you one that I think it's kind of likely you might make a mistake, okay? And that's okay. I'm giving you one that's kind of hard because I actually want you to try it, and if you make a mistake, that's okay, because I think you're going to learn more from making the mistake than if I just kind of told you, okay? So take a moment, pause the video, and try to find the greatest common factor of those 3 numbers, and then press play. Okay, so let's start with the numbers. I would start with the smallest number, and 12 has a lot of factors, right? Like I could do this as 6 and 2, and then this factors down. So 12 actually has, it can be 1 and 12, obviously, right? And then 2 is a factor. I could have also done 3 times 4, and then I did 2 times 6, so 12 has a lot of factors, okay? Now what we're going to do is we're going to start at the largest. Is 12 a common factor of each of these? So let's see. Is 12 a factor of 18? Can I multiply 12 and get 18? No, I can't, right? 12 times 1 is 12. 12 times 2 is 24. So nope. Is 6 a factor of 18? Yeah, 6 times 3 is 18. Okay, is 6 a factor of 24? Yeah, 6 times 4 is 24. So 6 is the greatest common factor of 18, 12, and 24. So I'm going to start with my 6. Okay, now a really common mistake when the greatest common factor is something like 6 is that someone will say, oh, the greatest common factor is 3 or it's 2. Yes, those are common factors, but it's not the greatest. So again, I would really encourage you to kind of list out the factors of the smallest number and then just work your way from largest to smallest. All right, now for the a's, this is a times a, This is a times a times a times a. This is a times a times a. How many a's do we have in common? I have one a in common with all three, and I have another a in common with all three. So there's actually two a's that are common factors. So my GCF is 6a to the power of 2. All right? Now, here's where we get to use it. Use that GCF. So next, we're going to be, go ahead and title, factoring out the GCF. We're going to be factoring out the greatest common factor, okay? And I want you to think of factoring as like unmultiplying, right? So we talked about how we've been going from factored form and then multiplying and getting into expanded form. So now we're going to do the opposite, okay? So here are your examples. So here's my first okay, I'm going to factor out the GCF. Here's what that means. My answer is going to end up looking like the GCF right here. Okay, the GCF right here. And then I'm going to have terms, in this case it's 1, 2, 3 terms. I'm going to have 3 terms, 1, 2, 3 right here. And what I want is basically a multiplication problem that if I multiplied, I would get this. Okay, so that's what I'm aiming for. But it starts with finding the GCF. So I'm looking for the GCF. The first thing I'm going to do is I'm going to find the smallest number, which is 6. Okay, and look, I'm actually going to do the work like off to the side here so that I can work straight down. Okay, and I've actually left myself some space to do the work, so I can do it like right here and just take up one line. But don't take up like all this space because then it's going to be confusing, right? As you do the work. I'm going to use this line to find my GCF. So 6, what are my factors of 6? My factors are 1 times 6, of course, and then I can do 2 times 3. So here are the factors of 6, and let's see what the greatest common factor is. So starting with 6, is 6 a factor of 9? Can I multiply 6 and get 9? And the answer is no, so 6 is not the greatest common factor. Can I multiply 3 and get 9? Yes, I can. 3 times 3 is 9. Can I multiply 3 and get 15? Absolutely, I can. So 3 is the greatest common factor. So we're going to start with 3. And then let's look at the x's, okay? And if you want to write this out, that's fine, but I think you can probably start to do it in your head too, right? If you can picture there's 2 x's here, and there's 3 x's here, and there's 4 x's here, how many x's are in common? Well, there's the 2, right? The smallest number of x's is what they have in common because there's 2 here. There's more than 2 here, but only 2 in common. There's more than 2 here, but only 2 in common. So the greatest common factor is 3x squared, okay? That's the greatest common factor. Now, here's the part that's new. What I want to know is 3x squared times what would get me 9x to the 4th. So we just say, okay, 3 times what is 9? Oh, 3 times 3 is 9. Okay, and then x squared times what would be x to the 4th? Well, this is x times x, and I want it to be x times x times x times x. So how many more x's do I need? I need 2 more x's to be multiplied. Okay, now, next, I want this to be a -6 right here, right? I want this multiplication problem to land on this answer. So 3 times what is -6? Well, a positive times a negative is a negative. 3 times 2 is 6. And then x times 1 more x would get me x to the 3rd. Okay, next, 3x squared times what would be 15x squared. So first, 3 times what is 15? 3 times, look, and you can do this. 3 times what is 15? Oh, 3 times 5 is 15. And it's positive times positive is positive. And this is, I'm already multiplying 2 x's, and I only have 2 x's on this term. So I'm actually not going to put another x here because I don't want there to be another x. Okay, so now I'm going to check my answer. And how am I going to check my answer? I'm going to multiply. Okay, so look, I'm going to cover this, and I'm going to do the multiplication I've been doing. 3 times 3 is 9. X times x times x times x. 3 times -2 is -6. This is x times x times x. That's x to the 3rd. 3 times 5 is 15. And this is x times x. And then what I'm going to do is I'm going to check. Are these the same? And I say, yep, they're the same. So therefore, this is my answer. Okay? I'm going to do another one. Look, this one's shorter. But it still has a GCF. Okay? I'm going to factor out the GCF. The first thing I observe right away is that this term has a variable and this term doesn't. So the GCF is not going to have a variable. Here, all the terms had an x. In fact, all the terms had two x's, so my GCF had x's in it. Here, that's not the case. So my GCF is just going to be a number because there's no variables here. So I'm going to start with 8, right? And I think 8, okay, 8 is 1, 2, is 3 a factor? No. Is 4 a factor? Yes. And 8 is a factor, of course, right? So this is 1 times 8 or 2 times 4. So is 8 a common factor? Can I multiply 8 and get 12? No. Can I multiply 4 and get 12? Yep. So 4 is my greatest common factor. And like I said, there's no variables here. So I'm just going to start with my greatest common factor, which is 4. Okay. And then I'm going to ask myself, look, this is 2 terms. So look, I'm going to make myself 2 blanks. 4 times what is 8n? 4 times what is 8? 4 times 2 is 8. And if I want it to be 8n, this has to be a 2n. 4 times what is 12? And notice, I notice it's positive. 4 times, look, and you can do this if you need to. 4 times what is 12? 4 times 3 is 12. Okay, and then look, here's my check. Okay, look, I'm going to check it right here. 4 times 2 is 8. 4 times 2n is 8n. 4 times 3 is 12. Did I get the same thing I started with? Yep. Okay, so that's what it looks like. These are your practice problems. This one's more like our second one, a little bit shorter. And this one is more like our first one, a little bit longer. Okay, and our goal is to be comfortable with both. Okay, take a moment, pause and try. Okay, here, hopefully you notice the GCF, there's no variable because there's no variable here. The GCF of 10 and 15 is 5. And then 5 times 2 is 10, 2p. 5 times negative 3 is 15. Okay, so your answer should have looked like this. Over here, when you're looking for the GCF, you should have started with 4 and said, okay, my GCF could be 1 or 4. 1 times 4 is 4. Or it could be a 2, right? Because 2 times 2 is 4. So does 4 multiply to 6? No. Does 2 multiply to 6? Yes. Does 2 multiply to 14? Yes. 2 is my greatest common factor. And then I'm looking at the A's. There's 3 A's, 2 A's, 1 A. So they all have at least 1 A. So that's my greatest common factor. 2A times 2 times 3 is 6. A times 2 more A's would be A to the third. 2A times, look, I'm trying to make this negative. So a positive times a negative is a negative. This would be 2A. And then 2A times what is 14A? 2 times 7 is 14. And I already have my A's. And I could just scoot this parentheses in a little bit. And that's my answer.